In this video, we're going to practice multiplying and dividing radical expressions. This is practice problems from section 6.4. Question 1. The square root of 3 times 4 square root of 2 minus 5. Because of this plus minus here, we're going to need to use distributive property. So when we multiply the coefficient times the coefficient, or outside times outside. That would be 1 times 4. And then inside the radical, 3 times 2. Then we'll do the same thing times the negative 5. Coefficient times coefficient gives us 1 times negative 5. And radical times radical, since there is no radical here, it's the invisible 1. So it would be square root of 3 times 1. So we have 4 squared 6 minus 5 square root of 3. On number 2, same process. Outside first, coefficients first, then under the radical, and then coefficients, and under the radical. On number 3, same process. Coefficients, 5 times 2. Under the radical, 2 times 8. And then coefficients, 5 times negative 7. And radicals. Square root of 2. Since there's no radical here, it's square root of 2 just times the invisible 1. Now, with this question, we need to simplify this square root of 6. In the other two examples, there was nothing to simplify, so we didn't have to worry about that step. Square root of 16 equals 4. That 4 gets multiplied times 10. So we have 40 minus 35 square root of 2. On number 4, distributive property. Coefficients, 3 times 4. Radicands, 10 times 2. And the next term, coefficients, 3 times negative 6. And radicand, 10 times 5. And now simplify. So the 20 is 4 times 5. This is the perfect and the extra. We know the square root of 4 is 2. That 2 gets multiplied times is 12 to make 24, and the square root of 5 comes down. Same process over here. The 50 is 25 times 2. So we know 25, square root of 25 is 5. It gets multiplied times this 18. 5 times 18 is 90. Square root of 2. These always just come down. Same process on number 5, distributive property. Coefficients, 2 times 1. Radicands, 2x times 14x gives us 28x squared. And then the next term, 2 times negative 6. And the radicands, 2x times x to the 5th gives us 2x to the 6th. And now we simplify. The 28 is 4 times 7, and the x squared is perfect. So the square root of 4x squared is 2x. It gets multiplied times that 2 out front to give us 4x, and we have the square root of 7 there. Over here, with the second term, there's no perfect square factors in 2, so the 2 is going to have to stay in the not perfects. But the x6 is perfect. So we'll take the square root of x to the 6th is x cubed times that 12 gives us negative 12 x cubed, and these not perfects come straight down. So we're done. And they just keep getting more and more complicated. Coefficient times coefficient, so x times x is x squared. Then the radicals. 3 times 8x squared y will give us 24x squared y. And then we multiply times this term. Coefficient x times 5xy gives us 5x squared y. And then the radicals. Square root of 3 times 3x cubed y squared gives us 9x cubed y squared. and now we simplify. So the 24 is 4 times 6. The x squared is perfect. The y is all alone, so it has to go in the not perfects. The square root of 4x squared is 2x. It gets multiplied times this x squared out front, and that gives us 2x cubed, and the not perfects come down, square root of 6y. And we're going to do the same thing with this term over here. So we have 5x squared y. 9 is a perfect square, so we'll leave it there in the perfects. X cubed can be broken down to be x squared and 1 extra, and the y squared is also perfect. So we're going to multiply 5x squared y times the square root of 9, which is 3. The square root of x squared is x. The square root of y squared is y. When I multiply these two together, I get negative 15. X cubed, y squared, and these not perfects, they come straight down. So there's our final answer there. On number 7, the difference with number 7 is now, well, if we scroll back a little bit, when we look at 5, we have a monomial times a binomial. This is two terms, one term on the outside, two terms inside the parentheses. On number 7, we have a binomial times a binomial, so both of these are two terms. It just changes the process a little bit. This is what I call double distributive. Some of you guys might have learned it as FOIL. So we're going to multiply this term times this term. We're going to do outside, 2 times 3, and then radicals, 3 times 2. Then we're going to do this term times this term, and we're going to do coefficients outside first, and then the radicals. Then we're going to do this term times this term, coefficients, and then radical, and this term times this term. And then we're going to scan around to see if there's anything that needs to be simplified. Square root of 6 cannot be simplified. Square root of 3, square root of 2, these are all good. Nothing can be simplified, so we're done. Let's do the same process on number 8. This term times this term, first the coefficients on the outside, then the radicands. This term times this term, first the coefficients, then the radicals. This term times this term, coefficients, radicands, and these two terms. And this time I do have some stuff I can simplify. For starters, we know the square root of 4. This is a perfect square, so we're going to simplify that. And these two terms here in the middle are like radicals, so we're going to add them. So the square root of 4 first is 2. That gets multiplied times the 15. That gives us 30. When I add these two like radicals in the middle, I have a negative 20 plus 9 makes negative 11 square root of 2. And I have this negative 12 down here at the end. But we're not quite done because this 30 and this negative 12 are also like terms. So we're going to add 30 and negative 12, and that will give us 18 and minus 11 square root of 2. All right, on number 9, we have still some multiplication. It looks a little different because of that exponent on the outside of the parentheses there. What I want you to remember is that when there's plus and minus or addition and subtraction in the parentheses, you cannot just distribute this exponent. Exponents do not distribute over addition and subtraction. So don't make the mistake of doing that. Instead, think of this exponent as being a signal that we're going to use 2 of this base. So we should rewrite this base, the square root of 3 plus 5 times another one, the square root of 3 plus 5. And this is binomial times binomial, so we're going to do that same double distribute process. So the coefficients here for the first multiplier, 1 times 1, and then the radicals, square root of 3 times square root of 3. And then here, the coefficient's 5, the radical is the square root of 3. Here, same thing, the coefficient is 5, the radical square root of 3. And then here, 5 times 5. And now we simplify. The square root of 9 is 3. These are like radicals. We add the coefficients and the radical stays the same. So 5 plus 5 gives us the 10 here. And we have plus 25 here on the end. But we're not done because these are like terms. So 3 plus 25 is 28, plus 10, square root of 3. Number 10 is the same kind of question. Remember, this exponent is not going to distribute inside here if there's plus and minus. It's okay to bring the exponent in if it's all multiplication in these parentheses, but when you put addition and subtraction in here, you can't do that. So we're going to write this binomial twice. 2 square root of 6 minus 7 times 2 square root of 6 minus 7. And we'll double distribute. So coefficients, 2 times 2. Radicands, 6 times 6. And then here, coefficients, negative 4 and radicand. And here, coefficients, negative 14 and radicand. And here, negative times negative makes positive. 7 times 7 is 49. Now we simplify. The square root of 36 is 6. Times that 4 makes 24. These are like radicals. Negative 14 and negative 14 make negative 28. Square root of 6. And we have plus 49. Almost done. Now we recognize that this 24 and this 49 are like terms, so we need to add them. 24 plus 49 makes 73. Then we have minus 28 square root of 6. All right, for number 11, we're going to do double distribute again. So first term, coefficients, 4 times 3. Radicands, 3x times 15x makes 45x squared. And then here times here. Coefficients, negative 4 times 1. Radicands, 3x times 3x makes 9x squared. And then here, radicands make 9x. 3x times 3. Sorry, those were coefficients. The radicand is 15x. And then here times here. The coefficient is 3x. That should be a negative 3x. Because we're multiplying positive 3x times negative 1 here makes negative 3x. And then the radicand, square root of 3x. And now we look for what can be simplified. So 45 is 9 times 5, and x squared is perfect. So that's going to make a 3x there times the 12. Square root of 9x squared is 3x. So 36x times square root of 5. Here, the second term, 9x squared is perfect. So we're going to have the square root of that is 3x times that negative 4 makes negative 12x. Here, 15x doesn't simplify. 15 doesn't have any perfect square factors. So this term is just going to stay 9x times the square root of 15x. And this term also does not simplify. So we're going to have negative 3x square root of 3x. That's really complicated looking. Is there anything else that can add or simplify? It looks like none of these are like radicals, so we can't even add them. So it does look like we're done. And number 12, more of the same. So this term times this term. And I know I'm doing this process because this is two terms here. A binomial times a binomial, we do double distribute. So when I multiply these two terms together, the coefficients are just 5x. The radicands are 6xy times 3x cubed, and that makes 18x to the 4th y. And then I do this term times this term. And the coefficients are 5x times negative 2x squared. That makes negative 10x cubed. And the radicands, 6xy times 2xy makes 12x squared y squared. These two terms, when I multiply them, I just have the negative 1 on the outside because the coefficients are both 1. Here and here. The radicals, 2y, 3x cubed. When I multiply them together, I get 6x cubed y. And then I multiply here times here. The coefficient here is -1, here is -2x squared, so that's going to make positive 2x squared. The radicands are 2y and 2xy, so that's going to make 4xy squared. And we're going to simplify next. So 18 is 9 times 2. X to the 4th is perfect. Y has to stay in the not perfects. So we're going to have 5x times 3x squared makes 15x cubed, square root of 2y. Next to that, we have -10x cubed. The 12 is 4 times 3. X squared and y squared are both perfect. Let me erase this. They're going to both go here with a 4. So we're going to have 10x cubed times the square root of 4 is 2, the square root of x squared, the square root of y squared. And that makes 20x to the 4th y and the square root of 3, hanging on. Okay, here, the 6 doesn't have any perfect square factors, so we will leave the 6 by itself. Y doesn't have any perfect square factors, but x cubed could be x squared and 1 extra. So that's going to end up being x square root of 6 xy, because the square root of x squared is x. Running out of room here. So this last term I'm actually going to do up here, and then we'll carry it down. If I simplify it up here, then we can carry it down here. So we're going to have 2x squared, and the 4 is perfect. The x is not perfect. The y squared is perfect. So 2x squared times 2y, and the square root of x is still there. So that makes 4x squared y square root of x. Whew. That was fun. All right, let's do the division, number 13. We talked about this a little bit in the lesson. There's a rule that states when you have two radicals, that's an A, being divided, you can put them both together and make one fraction out of them. It's only useful if the numerator is actually divisible by the denominator. In this case, 54 is divisible by 3, so we'll put them together. And we will divide 54 divided by 3 makes 18. And then we can simplify the 18 as 9 times 2. So we end up with 3 square root of 2. On number 14, we're going to do the same thing. We're going to put the numerator and denominator back together here to make one fraction. And then we're going to reduce that fraction. So 90 divided by 2 is 45. X to the 10 divided by x cubed makes x to the 7. And then we can simplify that. 45 is 9 times 5. X to the 7 we can break up to be x6 and 1 extra. So the square root of these perfects is 3x cubed, square root of 5x. All right, on 15, we're trying to find the area of a square. We did a little bit of area of rectangles in the lesson. We remember that area equals length times width, but since this is a square, the length and the width will be identical. So we're going to multiply 5 square root of 2 minus 4 times 5 square root of 2 minus 4. And we're going to multiply those together. Using double distribute, we'll multiply this term times this term. First the outside, then the inside. Then we'll multiply this term times this term, outside and inside. Then this term times this term, outside and inside, and these two terms. Negative times negative makes positive, so this is plus 16. And simplify. So the square root of 4 is 2, so this is 25 times 2. These are like radicals, so we can add them together. Negative 20 make negative 40. And then we have the plus 16. So don't forget, the 50 and the 16 are like terms, so we can add them to make 66 minus 40, square root of 2. And since this is area, we need to put some units on. This will be square feet, since it's area.